What did we talk about yesterday?
Kinetic energy.
What is kinetic energy?
The motion of energy.
The motion of energy?
Motion and energy.
It is the energy of something that's in motion, right? It's moving energy, okay? So like right now, while I have this, I'm moving it. Does it have kinetic energy? What about now?
No.
What kind of energy does it have? Potential energy. Awesome. That's what we are talking about today, okay? Now, potential energy is stored energy, okay? Potential energy is defined as a stored energy. Now, we said that my cup here has potential energy right now, right? Okay, what if I hold it here for like 1,000,000 years? What's going to happen to the potential energy? Is it going to stay the same? Is it going to change? Is it going to get bigger, smaller? What's going to happen? Okay, it'll stay the same, except for when I die, it'll fall to the ground. And then what will its potential energy get changed into? Kinetic energy, because as it falls from my dead, cold hands, what will it start to do? Move. There we go. No, you're supposed to laugh. It's okay. That's the point. I say stupid things to get you guys to remember stuff, even though you probably weren't laughing at me. Was it sneeze?
No, I was choking on my drink.
Don't choke. Don't do that. I don't want anybody to choke today, please. Maybe tomorrow, but not today. Okay. I'm a forensics teacher and I have to teach it in person now, so it's bad, okay? So, potential energy is stored, and like you guys said, when it starts to move, it gets turned into kinetic energy. Okay. Now, potential energy, it comes in a bunch of different forms. We're going to talk about two today. The first form we're going to talk about is gravitational potential energy. Okay? Now, how we would write that is basically just PE, grav. Does anybody remember what this is equal to? From like physical science or anything, anybody remember?
No.
MGH, okay? The M, what do you think the M stands for?
Mass.
What do you think the G stands for?
Gravity.
Is it just gravity or is it acceleration due to gravity? It's different, you guys. What do you think the H is? Height. No, you guys, Hertz looks like this and it's a unit. That's Hertz. And that's a unit, and we're not dealing with Hertz.
Hertz isn't physical. Not physical.
All right, so what do you think their unit is here? Joules. That's just a semicolon, you guys, to separate it. It's joules. It's still joules. We're still dealing with joules, thankfully. All right. So we have a person, and they are sitting on a diving board contemplating their lives. Okay? Now, this person has a mass of 65 kilograms. And this diving board is at a height of 3 meters above the ground. So I ask you, what is the gravitational potential energy? I shouldn't have to tell you what G is. You should have that memorized by now. What'd you say it was?
1,911.
What are the units? Woo-hoo! All right. Do you guys need to see how we got that?
I did 6 points. I'd like to.
We did 65 times 3 times 9.8.
Yeah.
Wait.
I'm not erasing that part. I'm only erasing this part.
Is your T always gonna be negative 9.8
It's 9.8
or 9.8?
unless we're on a different planet. And if we're on a different planet, I'll either tell you what it is or that's what you'll be asked to solve for.
Okay.
Okay, so who has ever gone cliff diving? Show of hands. Oh, your teacher is more interesting than you. I've gone cliff diving.
I'm scared of heights. No.
Third period, someone went, oh, really? Where? We live in Augusta. I was like, fair point. But during the summers, I worked at Woodger Scouting Reservation. It's a Boy Scout camp up in Blairsville, Georgia, okay? And we would get, like, Saturday off. That was, like, it. So one Saturday night, we were driving around, and then we were just sort of bored, so we just went to this place where my friend Preston was like, oh, I've gone cliff diving here before, and we went cliff diving. It was fun. It was pitch dark, too. Don't necessarily suggest that being your first cliff diving experience, like in the dark. It's a little weird, but your teacher's cooler than you. Take that. So we're going cliff diving, though. Now you guys can all say you've gone cliff diving. We're going to do it right now from a height of 46 meters, okay? You guys are all speechless. You're like, she's not cool. It's okay. It's fine. I'm going to take what I can get. Now his potential energy, his gravitational potential energy is going to be 25,000. What are the units? Joules. I want to know, how much does he weigh? Not his mass. I want to know his weight. What are the units for weight?
Newton. Oh. Then you gotta. Wait, hold up.
Okay, let's look at this. You guys should know this, but it's okay. I'll give you a free pass. So this is our equation for potential energy, right?
Right.
No. Okay, so what's the force of gravity equal to? What times what?
What?
The force of gravity, you guys. It's mg, right?
Right.
The force of gravity acting on you is weight. We've said this like a million times. Okay? So, how do we find weight? mg.
Okay.
How do you get mg alone? That's literally all you have to do. Is the potential energy divided by h. That will give you a weight. So tell me how much he weighs.
543.47. I got 4,000. I got
543.
I got 543.48. Wait, do we divide that? Yeah. So I got
Divide.
something wrong, my bad.
Okay, what's the answer? 540 what?
43.48.
What are the units? Newtons. Okay. Because weight, you guys, is not mass.
It's mass and gravity.
It's mass and gravity, okay? Mass and gravity. That's how you can weigh more or less on different planets based off of their gravitational fields, okay? So like on the moon, do you think you weigh more or less? You weigh less. Let's all move to the moon. I would.
If we all live to when you're relative, I guess how the weight will stay the same.
But I'll see a smaller number on the scale, Aaron.
I understand that. I fully understand that. But it'll stay the same. It'll still feel the same about it.
Now, before we move on to this next question, how do we get energy? Yeah, we eat, right? Food. Food gives us energy. What kind of energy does it give us? Which is? And what do we turn it into throughout the day? Kinetic. If you don't eat enough food, how do you feel?
I didn't need enough food either.
You feel tired. You feel sluggish. The answer here here is not, I feel great. We're not encouraging that kind of mindset, okay? So what we're gonna do is we're gonna eat a Cliff Bar. Who's had a Cliff Bar? No? I actually had a physics professor in college who he would hand out raisins to everybody, but if he could tell you were like really sad, he would give you a Cliff Bar. I got Cliff Bars more than I got raisins. It was just this thing. It was just this thing.
Raisins are good though. I wouldn't complain.
I would be like, oh, it's nature's candy. I was one of those. I love raisins.
Raisins are really good.
All right, so we're gonna say that a Cliff Bar gives us 8.87 times 10 to the 5 joules of energy. Okay? So we're converting all of this to potential energy, and it gave us potential energy. So we're gonna say, due to the Cliff Bar, we have this much energy, okay? Now, the mass of us climbing is 81 kilograms. So that's our weight. That is, well, that's our mass. That's the mass of our backpack, the mass of whatever we're using to get up the cliff. Okay. If you're in the process of sipping, it's fine, but. Okay, we want to know how high can he go? How high can he go up the mountain if he's climbing a mountain? How high can he get off of one Cliff Bar?
I'm confused. What's the 10 to the 5?
He ate a Cliff Bar. He's climbing a mountain. Him plus all of his stuff is 81 kilograms. How high can this one Cliff Bar get him? This one Cliff Bar worth of energy. So we would say, well, the gravitational potential energy is equal to what? MGH. How do we get H by itself? Okay, how high can he go?
1,117.41.
I got the same thing. 1,117.41.
What are the units?
The meters.
Yep, you guys got it right.
So we ignore that. Wait, it's height. Never mind. Take that back.
So that's how high he went off of one Cliff Bar. Now, what if he adds some extra stuff into his pack? So now the mass of him and his pack is 91 kilograms. Do you think this is going to be, is he going to get higher, not as high, or just the same amount? Show me how high he gets.
994. Okay.
How much?
994.61. Well, 62.
Yeah, I got the same thing.
This is how do you
Okay, calculator.
Here. To get the first number, hon, we took the potential energy of gravity, which is this, right?
Okay, yeah, I did that.
And we divided it by our mass, which was 81 kilograms, times G, which is 9.8.
Oh, that's what it is.
Yeah, she'll never give us G because we're supposed to know.
Yeah, you guys should know what G is.
Yeah, no way.
I know what it is.
We've been using it all year. All right, any questions on this so far? No? So we can go to another example? All right.
Was it 91?
Yeah. That's what everybody else is wearing it.
Yeah, significant figures was not it.
Yeah, we're not doing sig figs. Do I need to go back over that?
No. Over what?
Sheesh, okay. Lord have mercy. We got attitude today.
I never understood that.
Okay. That's like the only time I've ever gotten an answer from the entire class, especially so fast.
What, citrus? Oh, no, yeah.
Okay, we're back on the diving board, which is 3 meters in the air. We have a gravitational potential energy of 1,800 joules. What's the person's mass? I'll write the equation again. And then I'll move off to the side.
We're looking for the mass.
You're looking for the mass. What'd you say?
61.22 to.
What are the units?
I agree.
Kilogram.
Kilogram.
Oh, wait.
Yeah. I got it.
Okay, we said the gravitational potential energy. What do we move to solve for M?
GH.
Is that what everybody did?
Yeah.
Yeah? So we're good?
Yep.
Okay, we got one other kind of potential energy we're going to talk about now. Oh, Lord, I know. So this is just regular stuff, but what about things that are like elastic? Like rubber bands or springs, slinkies, things like that.
That slinky is no elastic, isn't it?
You pull it in and then you can compress it, you can extend, you can.
Wait, that's what elastic means? I thought it was like.
No, I mean you can like stretch it out. Well, think about it. If you stretch on a slinky, what happens when you let go of it?
Oh, you're not. Okay, elastic. I love that song.
Elastigirl. There we go. Okay. So if we stretch or compress a string or something like that, are we doing work on it? Yeah, because we're applying some sort of force and it's moving some distance, right? Be it bigger or smaller. Awesome. So what we're going to use for the potential energy of something that's elastic or considered a spring is that it's equal to 1/2 kx squared.
Wait, what's that called? Spring.
The potential energy of a spring.
I feel like this one's gonna be a lot.
Now, who remembers what the K stands for? No, we did spring stuff, you guys. Who remembers?
Oh.
It was the spring.
Constant.
Yes.
Oh, it was.
Now, the real thing. Does anybody remember its units?
That's a good
No.
question.
Newton meter.
Newtons per meter. Okay? What do you think the X stands for? Yep. Proud of you. All right. So we're going to do an example. So we've got a spring, all right? And its spring constant is 120 newtons per meter. All right? And we're going to compress it a distance of 2.3 centimeters. We want to know what is the potential energy of the spring.
Is it for this potential energy still joule?
Yep, still gonna be joules. Energy is joules. If we talk about energy, it's joules. So let's look at our equation of the 1/2 kx squared. What do we need to do?
You have to check this in.
Yes, we're gonna change the centimeters to meters. How do we get from centimeters to meters? What do you divide it by? So, what is it?
0.023
What are the units now?
meters.
Meters. Okay, can we plug it in?
Yes.
Awesome. We're going to have 1/2 times 120 newtons per meter times 0.023 meters. And don't forget that that's going to be squared. So see what we get as the answer. You're so smart. I'm just going to round that to 0.032. And what are the units? Joules. Okay. Now I have one other thing. It's the same stuff. I just want to make sure you guys know how to do it because it's something you have to do on the problem set you're about to get. Oh, yay, right? What do you do if, let's say, something says it stretches with a force of of 25 newtons over a distance of 5 meters. How would you get K out of that information?
Okay, you just said a lot.
You
Oh, I
divide really high by five.
Is it?
Okay, so we have a spring, right? Okay, we are going to use 25 newtons of force to stretch it a total distance of 5 meters. So, yeah, so since K has units of N over M, all you would have to do to find the spring force of that spring is say 25 newtons divided by 5 meters. And what would that give you? What are the units? Okay?
Yeah.
That's the only thing I can think of on your problem set that you wouldn't have seen otherwise earlier in the notes.